we now discuss the solution of a problem from the section complex numbers, and the question is related to sum of the squares of moduli of the solutions of a given equation. This question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is sum of the squares of modulus of all complex numbers z satisfying z bar is equal to iz square plus z square minus z is equal to. So we have to take this equation and find the solutions of this complex equation. Agreed? And after getting the solutions, take the squares of the moduli of these solutions and sum it up. Then that will give you the answer. We now discuss the solution of the problem in detail. We are given the complex equation z bar is equal to iz square plus z square minus z. So this is written as z plus z bar is equal to 1 plus I whole into z square. Agreed. Now we have z is x plus iy, where x and y are real numbers and where I is the under the square root of minus 1, that is the iota, that is the imaginary unit. Then this equation z plus z bar is equal to 1 plus I into z square will be z plus z bar, z is x plus iy, z bar is x minus iy, z plus z bar is 2 times x into 1 plus I into z square. Z is 1 x plus iy. X plus iy whole square is equal to x square minus y square plus 2i times xy. Now multiply. So this will be 2x is equal to 1 into x square minus y square, x square minus y square, I into 2ixy, that is minus 2xy, and that is the real part of after multiplication, plus I times of x square minus y square, I into x square minus y square, 1 times 2ixy, that is I times 2xy, that is I times I multiplied by x square minus y square plus 2xy is the imaginary part. Now equating the real and imaginary parts on both sides, and on the left hand side we only have real part, the imaginary part is obviously 0. So equating the real and imaginary parts, we get the first one is x square minus y square minus 2xy is equal to 2x, that's the real part. The imaginary part is x square minus y square plus 2xy is equal to 0. On the left hand side we don't have imaginary part. Let's call this as the first equation, second is the second equation. Agreed. What we do is subtracting the first equation from the second equation, then x square minus y square will cancel, then you will get 2xy minus of minus 2xy, that is 4xy is equal to minus 2x. You are subtracting first equation from the second equation. So you get 4xy is equal to minus 2x, and that will give rise to 2x multiplied by 1 plus 2y is equal to 0. This will give rise to x is equal to 0 or y is equal to minus 1 by 2. X is equal to 0 or 1 plus 2y is equal to 0, that will give rise to y is equal to minus 1 by 2. We continue in the next slide. Agreed. Let's take the first case. When x is equal to 0, take this x is equal to 0 and put it in the second equation. In the second equation, x is equal to 0. Then you will get y square is equal to 0. Y square is equal to 0 implies y is equal to 0. So therefore, when x is 0, y is equal to 0. Therefore, the solution z is equal to x plus iy, that is 0 plus 0i, that is 0. That is the 0 complex number. Agreed. Case 2. So let y is equal to minus 1 by 2. Take this one and substitute in the second equation. Then you will get x square minus y square means minus 1 by 5. Minus 1 by 4 and plus 2xy, 2y is minus 1, so it will be minus x is equal to 0. So you are putting in the second equation and clear the LCM. That means take the LCM throughout, then you will get a quadratic equation next, that is 4x square minus 4x minus 1 is equal to 0. A very familiar equation. So we will find out the solution x is equal to minus b plus or minus under the square root of b square minus 4ac by 2a, and that will give rise to x is equal to 1 plus or minus root 2 by 2. Agreed. So x is the two values and y is the single value, that is minus 1 by 2. So therefore z is equal to one of the x values you take 1 plus root 2 by 2 and plus I times minus 1 by 2, that is minus I by 2, and the r z is equal to the other real part, that is 1 minus root 2 by 2 plus I times y is minus 1 by 2, that is minus iy. Thus we got the solutions of that given complex equation. So the complex number z satisfying this complex equation, z bar is equal to iz square plus z square minus z r. We got three solutions, and the first one is z is equal to 0 and z is equal to 1 plus root 2 by 2 minus I by 2, and the third one is z is equal to 1 minus root 2 by 2 minus I by 2. So we got these solutions of this complex equation, and take the squares of the moduli and sum it up, then that will give you the answer. Agreed. We got z is equal to 0, then the second one and the third solution. Now mod z square is 0 obviously, and mod z square is equal to real part square 1 plus root 2 by 2 square plus minus 1 by 2 whole square, that is same as 1 by 2 square. And for the third solution, mod z square is equal to 1 minus root 2 by 2 plus 1 by 2 whole square. Now take the sum of the squares of a moduli, and anyway the first one is 0. So this will be equal to 1 plus root 2 whole square plus 1. We are taking the LCM 4. And 1 minus root 2 whole square plus 1 by 4. The 4 is the common LCM. Now we got now here 1 plus root 2 whole square plus 1 minus root 2 whole square, that is a plus b whole square plus a minus b whole square, that is 2 times a square plus b square. That will be 2 times a square 1 square plus b square root 2 whole square, that is 2, plus 1 plus 1 2 whole by 4. When simplified, you will get 8 by 4, that's equal to 2. Thus the sum of the squares of the moduli of the solutions of the given complex equation is 2. So the answer to this question is 2, and that is the detailed discussion of the solution of a problem from the section complex numbers. I am sure that you have understood the solution of the problem, and I wish you all the best. Thank you.